Good morning, Mir. Good morning, Arman. We will start in few minutes, okay? Let everybody join. Yeah, is it visible to everyone? That presentation slide, CPU? Okay, so I think it's, yeah, thank you, that's. So how was the day? Physical classes is going to start soon, okay? Because that first year, last year is already started, and I think that rest of the class is also going to start it soon. So be ready for that. Yeah, and the continuously we are meeting in online, and that emotional touch is not just developed. So when we meet personally, definitely we'll have a kind of the strong discussion on every topic and every set of the kind of the problems in this subject or anything that we are going to discuss over there. I want to inform you that that assignment of task chapter number 3 is already has been published, so you can access it from Canvas and submit it before the deadline. And chapter 4 also we have completed, so that assignment is going to upload it in a few days. Okay, so keep checking your Canvas portal for the assignments and all this stuff, and don't miss the anything from the Canvas to get the good marks. Okay. In just 2 minutes, let me start. Okay. Yes, so let me start. So there are a fifth chapter. Fifth chapter, which is the name is a central processing unit. Okay, and in the central processing unit, that's the topic that we are going to discuss, which is first the introduction. What is CPU? Then what is the general register organization? How the different register has been organized? What is the stack organization? What is instruction format, addressing modes, data transfer and manipulation, program control, risk architecture. This is all stuff that we are going to discuss in this particular chapter. Okay, so let me start with the first, which is introduction. So SPC, it was started with the stored program computer, or we can say what is the meaning of that? It's a program and the data are stored in the same memory, also called as a Van Neumann model or Princeton architecture. Example, which is a desktop system. Okay, So we can say SPC, stored program computer, your program data, program and your data. Like we can say there are same stuff. I can say if you are having a computer desktop system you have, so in desktop you have a dedicated one storage. Okay, we can say that's one storage. It's available over there. That is connected in the same location. Whatever your program is there, whatever your we can say memory is there, or as well as your data is there or program connected in a same memory location, which is called as a Van Neumann architecture. That we can say desktop system. Now there are a question are there if it is connected in SSD, in HSD, what are the all the stuff is there. But I'm talking about that the stuff where common system is there, where commonly in HDD also both this stuff is going to be stored. So these are the first definition of that. What is a stored program computer, which is having the same storage for memory as well as the data. Harvard architecture, which is having a program and data are stored in a different memory, which is a microcontroller based system. Now microcontroller based system and DSP, it means you can consider like that you are working on some embedded software or embedded project, like you can say automatic traffic light control. Okay, so automatic traffic light control can be controlled by one Arduino based, or we can say one specific type of the microcontroller board. Okay, first of all two things you need to keep in mind over here. There are a first name which is a microprocessor, another is a microcontroller. Now, what is the basic difference between them? As we have discussed on a previous in a previous chapter, RISC and CISC architecture. Okay, so RISC architecture is directly applicable for the microcontroller. CISC architecture is directly applicable for the computers. Okay, so computer CISC architecture having a flexibility to changes in your system. It's not limited to one functionality. Many functionality you can target with that. Those are the computer CISC architecture. While limited functionality, limited things, limited memory, that we can say do with the RISC architecture. That's the microcontroller. So microprocessor come under the PC, laptop, and such type of stuff. While another embedded system like traffic light control, washing machine control, oven control, refrigerator, this wherever the electronics device is used for the specific purpose only, those are the microcontroller reduced instruction set architecture. Okay, so you can also say that CISC architecture is going to be a Neumann model, one Neumann model, and RISC architecture is a Harvard architecture. Okay, because it is having a program and data has been stored in a different memory. It means you can attach extra memory to do the extra storage, like whatever the storage available for that microcontroller, which is limited. If you want to do more thing with the external storage, so you need to connect the storage chip with this particular microcontroller. So that we can say the different storage stuff, we can say, and we can say there are a different storage is going to be allocated with them. Now you can ask me the question like this stuff like if I am purchasing a desktop, so hardware and processor both are going to be different. Okay, so how you can say that hardware and processor both are going to be different? Why it is not come under the Harvard architecture? Over here, you need to think like that whenever you purchasing any desktop or any computer. Okay, so whatever the final display devices, or we can say final structure that you are talking about, and final that byproduct you are talking about, if you are not connecting them HDD, okay, then entire system is not going to be performed. How you can load the OS, and that's going to be a we can say that's going to be a questionable of that. Like आप अपने सिस्टम के साथ आप HDD स्टोर ही नहीं करते हो, आप उसके साथ अटैच ही नहीं करते हो, तो आप अपना OS कहाँ पे लगाओगे? That's the first thing. While in a microcontroller, they have their we can say directly their particular predefined their engine is there, and you need to just give the instructions. You just need to load the program, And in that architecture, whatever your program has been loaded, it's going to be accepted by them and they start working in that. But if you need an extra dedicated memory, okay, to connect with them, then you need to connect the extra devices. It's not by default is available with them. Microcontroller 5 GB RAM 100 HDD के साथ नहीं मिलेगा. It is going to limited storage, or we can say it's a separately it's available. While whenever you go with the computer or one Neumann model, whatever the data and the program, whatever the stuff is there by default, memory is there, which is one architecture. Let we will see one by one and we will check what are the things we have. The general register organization, if we can talk about this particular stuff. So general register organization, when larger number of processor register inside CPU, they are connected as a common bus system. Okay, if there are lots of register are there, IR, this, so that all are going to be connected with the common bus system. Decoder, which is a select a particular register, and we can say that that's a task of decoder that we already discussed. Like what decoder will do, whatever the selection line you have given, according to that, it will give you the output. Okay. Output of each register is connected to a 2 multiplexer to form the 2 buses A and B. Okay. So we can say out of the each register having a 2 multiplexer. While what about the first side and what about the second side, A and B? I can say selection line. It's in each multiplexer selects the input data for the particular bus. So if we can see the overall architecture, it is look like this one. Okay. So to do the arithmetic and logical operation, you require 2 data. That actual 1 register data and 2 register data. Like you require the 2 separate register to work with this one and this one. Okay, and ALU cannot perform the ALU like you are doing arithmetic operation. So at least you need to give a 2 bit to operate with that, and result is stored in another register. So you require a 2 bus, 1 for A register, 1 for B register, and that both register is connected with the all the register pair over here. Okay, or we can say that all the particular blocks are available over there. It's connected to both of them. It's connected over here also, connected over here also. So data of this one can be go over here, it can go over here also. Okay, multiplexer, that selection line will choose that right now out of this all register which I need to include in my system. Like I can say I want to do the task with R1 and R2. So R1 is going to be, so selection A line you need to give, so R1 will come over here, and selection line B you need to give such a manner that R2 will come over here. So likewise both register will enter into these separate marks, and it will come under the A bus, B bus, and the arithmetic and logical unit going to perform that. Okay, so that is also going to be stuff like that. Whatever the result generated from this ALU, okay, after performing the data with A register and B register, whatever the output is there, output is stored at where? It is stored in R1, R2, R3, R4, where? So whatever the selection line you have given, in a decoder you have given 0, 1 to 7. Depend upon the number you have given, that register getting enabled and the data is going to be stored over there. So you can take example that whenever I'm doing the stuff like add, initially I will just doing the addition of the data available in R1 and R2, and result it will store in R3. So what it will be like, R1 will come into the mux of, or we can say R1 will come to the A bus, and to do that in mux I need to give a 0, 0, 0 because it's a first line. We can say that's 0, 0, 1, that's the first line. 0th line will be the input from the external, I can say. So the overall stuff you can say by using a mux, selection line, buses and all the things, the data is going to be interpreted with that, and again it is stored back to that location by giving the selection of decoder line. So that's the all thing is mentioned over here. Decoder will do the what, selection line will do the what, and all the things. This stuff already we have discussed in the second chapter. So this is just about the glimpses that what actually the organization is there. How you just select the multiple lines, Sorry, yeah, and how the data is going to fetch in one particular location and so on. So this is for the understanding purpose. So I need to transfer the data R2 minus R3 transfer to R1. For that 0, 0, 1 I need to give. So R2 will get enable. Data will come over here. 0, 1, 1. R3 get enable. Data come here. Then after you give the 0, 0, 1 over here. So data going to be make enable R1 and data is stored like this one. So it will be like this thing. Initially R2 came, R3 came, both going to become A and B bus. Output by giving the decoder line is stored in R1. So this is a little bit of animated view for the overall structure. Okay. This is a thing we have R1, R2. If we have R4 and R5, okay, you need to do the logical operation and data come to R4. What are the process for that? 1, 0, 0. So R4 selected, come into the first mux. R5 selected by 1, 0, 1 over here, and it will enter into the, sorry for the interruption. Then it's going to enter into the mux B. Both will come into the A and B bus. Giving the decoder 1, 0, 0, it will selecting the fourth one, and data is going to be stored in R4 through this output line like this one. Okay. So over here there are operational code is there. Operation code, it means you have seen this previous block. I'll show you the previous block. Just give me a minute. Yeah. Over here OPER there. Operational block, it means you are actually giving instruction to arithmetic logic unit that what you are doing right now. Are you doing the add? Are you doing ending, ORing? So for that we have discussed opcode are there, or we can say control signals are there. Okay. So in previous chapter we have discussed there are some opcode generate control signals and that which is given to that ALU, and according to that that block gets selected and data processed with them and prescribed, or we can say that suggested output is generating from that. So OPR for the addition is mentioned over here. Like OPR for the addition will be 0, 0, 1, 0, 1. While the same stuff for the logical operation, ORing operation, I can say, which is going to be like 0, 1, 0, 1, 0. So this is the overall stuff here. Now R1 to R7, you simply need to transfer R1 into R7. So for that, that's the register transfer instruction. Previously was the arithmetic and logical equation. So for this R1 and R7, R1 transfer to R7, mux A selected, mux A will get the data and directly you just need to give the opcode to R7. So just feed the opcode all zeros and data is going to be transferred to R7. So at that time mux B is not required to perform, only mux A can do the overall stuff. Okay? That's the stuff. So there are a general register, that's the organization, and we can say, and whatever the things that I have explained you and this animation, that's the overall thing we have. That's the second level. So continuously sneezing. Some question in the chat box. I have forgot to read that. Please hold assignment and experiment because our third sem exam date and when it is announced, man. I didn't get the information. GTU when it is announced, GTU timetable. Let me just check it. Bachelor of Engineering. Oh yeah, third, yeah, official ho gaya. हाँ? So when it is starting from 1st March. Yeah, it is starting from first. So what is your department code? Can you tell me your code? 011 or What is your subject code? Branch code. What is your branch code, man? Tell me. Third semester, what is your branch code, my friend? Tell me. Hello?
16.
Sir,
16. Yeah, yeah.
God.
16. So, this the data structure, DMS, digital fundamentals. Yeah, DF and all the things. Yeah, so that's your exam is starting from 1st March up to the 8th March. Yeah, so you have a time of 2 weeks. So I'm not going to upload any new assignment now. Okay, all the assignments that we are going to do is going to be after your examination. So that I'm going to incorporate. Okay, don't worry about that. Whatever the pending assignment is there, I will give you the time also to do after your examination. So you better you are prepared for the exam. So don't worry about that, everyone. So once that date will be declared regarding the reading and all stuff, so we will give you the time for that also. Okay, so don't worry. So no new assignments up to your examination end. Don't worry. Okay, that's a good thing that you have reminded me. So this is the thing, but somehow today we need to just complete this lecture because it's already started. So that we will see what are the things we have over here. Yeah. So as per the examples we have, like this is the same stuff. Like if you want to do the O-ring of R1 and R2, so it's simply like just place your selection of register A001, 010. So A will get the R1 data, B will get the R2 data. If you want to do the operand 10010, it's perform the A plus B. So just give that operand to your accumulator, and then you need to select the decoder of 011. The result is going to be press in 3. So that's the same stuff, same example that we have discussed in that animation. So from this one, these are the some of the things we have. Like if we have a binary code 000, then it will take an external input. It is possible that the stuff is not directly on the we can say internal storage register. That data can be also from the external input. So it's possible that for the binary code 00, your selection line will give you the external input, and selection line D, nothing is going to be there. Okay. But while for the other selection code for register, for the multiplexer or for the decoder, okay, whatever the binary code is mentioned related to that, those register is going to be selected. So either you're giving in a decoder 3 line or you are giving the selection line. Both going to be same. It's give you the related access of those particular register. So these are the all thing we have. There are a stuff. What are the opcode is there? Okay. So in the ALU, the different opcode will be like transfer A, increment A, add A plus B, subtract A minus B, decrement A, and or XOR, complement, shift right, shift left. So all that transfer, increment, addition, subtraction, decrement, so that arithmetic, and or XOR, that's are the logical, complement also logical, then shifting the operation is there. So to all of them, you are having a OPR. It's selected like this one. So by looking to this table, you can get the anything. Like if you want to make end of A and B, so you need to give the opcode this one. Okay. And what would be the selection line? It's depend on the register that what is the register that you are choosing. If I'll give you the example that this is a table, okay, and this is the opcode. If I tell you that, just you need to give me the answer by opening the mic. If I tell you that, if I want to make addition of register R1 and external input, and I need to store it to R2, can you tell me what is a selection line A, what is selection line B, what is selection line D, and what is the opcode? So this is a two table I have. Again, I'm repeating question. I want to make addition of data available in R1 and the external input, and I need to store both of the addition into the R2. So what is a selection line A, selection line B, selection line D, and the opcode? Can anybody tell me what about the selection line first of all? Open your mic and tell me. Yeah.
001.
Yeah. So
For
first
R1.
For R1, selection line A will be 0, 0, 1. For the selection line B,
0, 0, 0.
Yeah, selection line B will be 0, 0, 0. So it will take an input. And what about selection line D?
0, 1, 0.
Yeah, true. 0, 1, 0. And opcode will be addition. It's a 0, 0, 1, 0. Have you got that, everyone? So such type of the thing, if you just make it as a kind of the selection, so it will give you the specific kind of the output for that. Okay. Now by looking to this architecture, you can say like that that entire operations, okay, that can be controlled by the giving the different selection line, different control logic to the different block, and those stuff is executed. So that all the thing we are discussing in a previous lecture also, like we are having a lots of stuff, like we are having things related to how to generate a control signal for different block, but always there are a question where those control signals are used. Those control signal are used over here to select this multiplexer selection line, giving the opcode to this one, and so on. Okay. Next we have general register organization. So what is a control word? It's combined values of input and operational bit. It's a 4-field like SC, selection A, selection B, selection D, selection operand. So we can say by generating a simple control word, if you have a common control word, it will get all the data to all the multiplexer and decoder. Like आपको सिर्फ ये एक ही वर्ड आपको जनरेट करना है, आपकी पूरी जो इंस्ट्रक्शन है, अगर आप ऐसा कर रहे हो कि मुझे एड ए बी करना है, so for add AB, you need to generate a control word which is having all the 4 fields. जिसमें selection A का data भी हो, B का भी हो, D का भी हो. Yeah, somebody has raised the hand. Please ask the question. Hello. Check. Yes, Pankaj Kumar. Yes, Pankaj Kumar. Ask the question. Pankaj Kumar, ask the question. Pankaj.
By mistake, sir.
Okay. So that over. Okay. Yeah. By mistake. Okay. So if you are having a stuff related to like a control word, so that I have told you, you need to generate a single control word which is having all the selection unit or selection type of the things or selection type of the beats are there. And one by one, if you give those data to each and every block, so you will get answers out of that. So there are 4 fields which is having operand A, B, and D. So if I can say I have the instruction register R1 equal R2 equal to R1 plus R3. So for that, from the table I can get the simple stuff that I have done the practice of that. Like I want to select A to R1, B to R3, D to R2, and operand should be add. So for that, what is the control word I have? 0, 0, 1, 0, 1, 1, 0, 1, 0, and 0, 0, 1, 0. So if I generate a such type of the control word for this micro operation, so directly addition of the both number is going to be happen. And that's the overall thing we have whenever such type of the assembly code like add R1 plus R3, if just for example, if such type of the stuff will came, so definitely as a control signal, you need to generate a such type of the bits. And you need to give it to the different control blocks. So automatically it will do the addition of the two numbers. Okay. So what are the questions over here? Okay. Computer has a 16 register, an ALU with a 32 operation, and shifter with the 8 operation, all connected to common bus system. Okay. So what is this thing we have? You have a 16 register. As we have R1 to R8, such type of the 16 register we have. One arithmetic unit is there, and it is having a supportive 32 operation. Okay, 32 arithmetic and logical operation and 8 shifting operation. Okay, आपके पास 32 arithmetic ALU के operation है, add, subtract जैसे, ending, oring likewise. and you have 8 different shifting operation, left, right, rotate, like this stuff, which is connected to common bus system. Formulate the control word for a micro operation. आपको control word बनाना है for a micro operation, as well as you need to specify the number of beats. We can say number of beat, which is in each field to control that word and give the general encoding system, as well as show the beats of the control word that specify the micro operation R4 equal to R5 plus R6. Okay. We will check. Solution. What is the solution for that? Solution for that, which will be like this one. 16 register beats. A 16 register need a 4 bit. Obviously, to select the 16 register, you require the 4 bit. So 4 bit, you required for source 1, source 2, because you have a 2 register. So each required a 4 bits. ALU operation need a 5 bit. Why? Because the 32 operation are there. And shifter having a 3 bit. So you require the 3 extra bits. So I can say 5 bit is used for arithmetic operation, 3 bit for shift operation. Overall 8 bit you require as a opcode to operate with the arithmetic and logical unit and shifter unit. And destination also 4 bit, because you need to store the same result into those register pair. Okay. For the R5, R6, and we can say that add and shift operation, it is defined like this one, like 0, 1, 0, 1, which is R5, 0, 1, 1, 0, which is R6, and destination is R4. So our question will be R5 plus R6 equal to R4. So that's the stuff I can say. R5 plus R6. R4 will be 0, 1, 0, 0, because it's a register 4 you need to show as a destination address. Add operation. So for the add operation, you can say you have chosen the stuff related to from this table directly. They have given the any random number for the addition over here. I can say that's the 0, 0, 1, 0, 0, 0, 0, 0 for the shift. Okay. And stack organization and all stuff. So what we are going to do, I'm just expanding this particular question. Okay. This is a question, same thing. What you need to decide in the register and what you need to do the stuff, that is, I think, clear with you. But what you need to do now with this question, this is a question, you need to design a such type of the table. Now its table is up to you. Okay. It is your point of view, like which opcode you are giving to which particular operation. But identify your favorite 16 arithmetic and logical function. Okay. Favorite 16 arithmetic and logical function. आप फाइंड आउट करिए कि आप कौन से 16 लॉजिकल और अरिथमेटिक ऑपरेशन रखोगे. ऐड, सबट्रैक्ट, ऐड विद कैरी, सबट्रैक्ट विद बोरो, एंड और एक्सओर, एक्सनोर, whatever you like. Okay, complement and everything. Also choose your logical shifting operation also, that is mentioned over here. That's a shifting 8 operation also you want to choose, and you need to design a such type of the, I can say, table with that. First you need to design such type of the table that this is a encoding or OPR for ALU, another table for encoding OPR for the shift operation. This is a encoding register selection field. So this 3 table you need to create now in the next half an hour. Is it okay with everyone? I'm not asking you about creating such type of the diagram. Diagram is the second part. If you finish those tables, then you need to go with the creating such type of the diagram in which there are a 32 register are there, and there are a mux is having there are some operational code base accumulator is there, in which there are a arithmetic logical operation as well as the shifting operation you can do. Is it clear with that? Right now I am saying that in the next 20 to 25 minutes you need to simply just enter, there is a different this one table for encoding register, for the ALU, and for the shifting operation. Is it okay with everyone? Have you got my question? Yes or no? First of all, type your confirmation in chat box. Yes, no, yes, no. I need confirmation from everyone. You just need to create a 3 table in the next 25 minutes. That what is your 16 arithmetic operation, 8 shifting operation, 32-bit access table for the selection line A, selection line B, selection line D. Okay. So start making that. I will make one portal in the Canvas. So you need to submit your answer over there. So write it in a notebook. And once I will open that, you need to just do it over there. Okay. So start writing that. Meanwhile, let me just, those who are in the middle of the lecture, let me just take the attendance of that. And then you will free to do the task. Okay. Just let me take your attendance over here. So for a few minutes of time, please pay attention for the attendance. So we have started with the CPU, and there is an introduction and general register. Link that I'm going to test it soon. Yeah, start with the number 37.
Yes, sir.
Yeah, speak up the number one by one quickly.
2,
And
3.
Just a second. After speaking the number, it's not allowed to exit from the class. You need to do the task over here. Okay, so don't just exit it from that. Yes, after that 3. 4, Syam. Next number 5, 6, 7, 8, 9.
9, sir.
9 is there. 5, 6, 7, 8. Anyone? 10, 11, 12, 13.
12,
12,
13,
13,
14,
14. Okay.
15,
15,
16,
16. After 16.
18,
18, 18,
20,
20,
22,
22, okay.
23,
23,
25,
25,
26,
26,
27,
27,
28,
28, 30, 31, 32, 33, 35. Just speak up your name.
35,
35,
36,
33, 36,
36,
36 is done. 33. Any number from
30,
37. 30, Pooja Ben. Okay, chaliye. Next. 38, 30, 37 is done. Saurabh Tripathi, see your number is right over here. 38, 39, 39, yeah. 501,
38, sir.
38 is
Sir,
there, yeah. Oh,
IT
yeah.
16, IT 21 present.
IT 21 is present, okay. Next number.
sir, 10,
502,
502, 503, 4, 5, 6, 7, 8, 9, 10, 11.
503, 503,
5010,
5010, 4,
508,
509,
508, 509.
510,
Ek.
510,
510 has done.
507,
508,
508, 507. Okay. 505, 506.
502,
What you are? Wait. Let me share my screen. Let me share my screen. Let me share my screen, man.
6010,
Yeah, see that. 6010. 6010. Okay, done. Chaliye. See the number. If there is a missing number, tell me. 5.
IT 11,
Me, Dobaria.
IT
Make-
32,
Just a second. Let me ask. 604, 004 is there. Shyam is not there. Number 5, Kirtan.
yes, sir, present.
Okay, 6 number. Krupal. 7 number. Kunal. 8 number. Awadh Kumar.
Hello, sir. 86.
Okay. Okay. IT6. Yeah. Then number 11. Kushal.
Yes.
Number 17.
Yes,
Harshit.
Yes, sir.
11 and 17. Okay. 31. 32.
Yes, sir. 32.
31 is there? No. 200 series 1, 5, 6, 11. Who's there?
11.
0, 6, 11. Chaliye. Next. 1, 5. Anyone is missing? No? Okay, done it. So start writing that. You have a 20 minute of time. So complete it within that particular stuff. So let me put this screen in a kind of the question mode so you can get the better idea from that. Yeah. So if you have any question, you can just open your mic and ask me, okay? But design a 3 table for this. Okay, design a 3 table for this particular system. Okay? If you have any question, you can ask me. Just a second, there are some, sir, 05 and 07 is present. So previously only 40 student is there. As I have started taking attendance, 44 student has been came. 4 students is directly increasing during the attendance time. That's the great stuff. Okay. But एक week है बाद में तो physical आएंगे तो कहाँ पे जाएंगे? So don't worry, you can take. Okay. Number 5 and number 7 is there. Yeah, 5 and 7 I have 7 has been present. Yeah. Yeah. So start doing this stuff, everyone. Okay, okay, not an issue, Kunal, not an issue. Okay, good one, good one, good one. So, Bhavin, if you don't use the mic, good one. Bhavin, mute your mic. Okay, good one, Bhavin. Thank you.
दुकान पे थी पता नहीं था दुकान ही चली गई नमस्ते उससे नहीं कर नहीं हम खबो आबो दुकान पर उन्होंने लगा दे छै वह ईयरफोन कान में बाजैत
Just mute your mic, Om Prakash Kumar.
हमर नाम है बुलंद बात
Om Prakash, mute your mic, please. Yes, students can leave. Just write your enrollment number, name, then they can leave. But completed this task before the end of the next lecture. Okay. Yeah. Thank you very much.